Hello and welcome to TidyX episode 74. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick, and TidyX on Twitter at Tidy_explained, or via email tidy.explained@gmail.com, or go to the GitHub repo. You can open up an issue and ask a question, or you can like and subscribe on the YouTube channel and also comment there, and we'll try and get back to you. And today we got an email, so we're going into the mailbag and pulling out some email from
Tim.
a person named Tim, who asked about joins.
Yep.
Particularly joins we're working on SQL databases right now. So, well, I take that back. We're not working on SQL databases. We're working on our accessing SQL databases,
Yes.
technically, is what we're doing. So we're going to talk about joins and maybe some reasons why you would do them in the SQL environment versus your R environment, etc. The joins work the same way in terms of the verbiage: left join, right join, full join, between SQL and R. I actually have an old blog post from a few years ago that goes over these and the syntax for them in R. So I'll probably
link it below.
I'll link it. Yeah. I'll link it below. But yeah, so that's what we're going to do today. We're going to go through our database. We've been doing NBA data inside of a MySQL database that we sort of build and connect to. And let's check out joins.
Let's get this thing going. I will share. Oh, yep. Share the screen with you so people right now are not seeing anything. But yeah. Here we go. So now we've got the database up, or excuse me, not the database, our studio up with our information here. All right, so this is our script that we're going to be going through today. As always, we're loading a bunch of packages at the very top here. So we got tidyverse, rvest, tidyverse for all our data manipulation et al. Needs, rvest for web scraping, which we're going to do some more of, janitor for some nice handy-dandy functions, RSQLite and DBI for accessing and creating the database, which is once again a local database. So it's on my computer. It's an RSQLite or a SQLite database, which is a little bit funky compared to normal databases, but it behaves functionally the same for us. It's just that way I don't have to have an actual database.
Yeah, a little different than a normal SQL database where you'll need a SQL Server client to access it.
The whole thing. Yeah, this is a lot easier. And then the library micro benchmark, which we haven't used in the past, I believe, but we use this for benchmarking, which is comparing two sets of codes.
Did we not use it once before to check?
Hey, if our viewers want to remind us, make a comment.
Let us know what episode
below.
It was. Let us know.
Let us know. I don't think we have. We might have talked about it in the past.
Maybe
with profiling, because it's a very helpful tool.
Yes.
But yeah, so this will tell us when we run two chunks of code, which one takes longer than the other. Mm-hmm. All right, so first thing we have to do is actually get our data. The last several weeks we've used data from a series of years and getting a bunch of information about NBA, like wins and losses. Here we actually want to pull some game level information, specifically play-by-play data. And so we're going to go through this at a very high level because we've covered web scraping significantly in the past, but I want to go through this so you understand what's going to be in our database. And so I have this function, pull game PBP data, which is pulling the play-by-play data. I pass it a game ID, the database connection, and then the argument verbose. And so this is for my debugging. And so it's set to false, but I can change this to be true, which then in the very first set of lines here in the function will then print the actual game ID. That way I can see which game it failed on. And now I'm going to be pulling and web scraping two different websites from ESPN, the play-by-play data set as well as the game level information. And this is why we have game ID. So game ID is actually a number that ESPN has now assigned to the actual game. So they have some sort of algorithm or whatever in the back end that determines the number. I couldn't figure out the logic behind it.
Either them or the NBA.
Yes.
They might just be taking the NBA game.
Might be. But yeah, so I just kind of went with that, and I found some game IDs. Then I'm going to pull some game level information. So from the play-by-play website, I'm going to pull the competitors and specifically then the home and away team information. And so each of these contain, it's a vector of 3. That is the location, the team name itself, and then the abbreviation for the team name. Then we're going to pull in some game level information, specific game. And so this is going to be pulling in the date that they played at, the date and time. This is going to be pulling in the odds ratio, or not the odds ratio. We're not talking about statistics. We're going to be pulling in the odds, so the bookmaker's odds for this. So this is the over-under and the point spread estimation. And then this is the capacity of the stadium, so the number of people that actually showed up versus the total number that the stadium could potentially hold. And then this is pulling out the game summary. So in this data set specifically, we are pulling playoff games. And so we're pulling information such as which is it, the West, the East, and then which game number is it. It's going to throw that into a simple data frame that is one row, and we're going to call that game df, and that's going to have all that game level summary information in that data frame there. We're going to throw it into janitor clean name, so they all have a nice clean name that's not ugly, even though we kind of made the names up there. And then here we're going to be pulling in the play-by-play information. This is just basically a copy and paste from the, I think it was episode 62, that we go into a lot more depth about what's going on here, but we're just pulling play-by-play information for that, so we're not going to go through there. And then I do a quick mutate to then add a play ID number to all the plays, so that way we have a reference going forward. I'm going to write the play-by-play information to the database. The table that it's going to be called is game underscore and then that game ID, that unique number. So that way we have a unique way to access the play-by-play information. And then here is a rather convoluted way of me determining whether the table game IDs exists or not in the database. If it does, or if it doesn't, then it'll create the table and add just games df to it. But if it does exist already, I don't want to overwrite it. I actually want to be adding to it. And so here it's going to then, if it does exist, it'll read in the table game IDs, append the game information to it, and then write it to the database. And there we go. So that is how the function that gets all our, here, let me make sure I loaded all our libraries. I tend to forget to do that. And so now let's connect to it. And so let's pull it. So we're just going to use a walk statement here from per. So we're going to walk over these 4 different game IDs, which I found from the ESPN website by manually looking at the actual URL code there. And I'm going to pull all the play-by-play data and write it to our database. So we're going to actively run that and then disconnect. And that's all our data, and I've been doing a lot of talking. So Patrick, once that completes running, why don't you take us through the next piece, which is interacting with our database.
Okay, we've done this a few times over the last 3 or 4 episodes. So we've disconnected from the database. Remember, that's a thing to, a habit that you want to have just so that you don't have database connections floating around in your working environment. So since we've added data to the database, updated our tables, and disconnected, we need to now reconnect, which Ellis has already done. So we use that db connect function to do that. And then the list tables function is just the handy dandy one that tells us what's in there. So we scrape those 4 games from I think it was all Eastern Conference Finals. Maybe there was a Denver Nuggets one in there. So maybe there's one Western Conference playoff. A couple Eastern. So he's got an Eastern Conference bias.
It was the easiest one.
Yeah, that's what he scraped. Okay, so that's the list of tables within there. Okay, so let's go ahead and look at some of this game info. So here we're going to pull from the game IDs game info for that East first round game. We're going to filter out the Eastern Conference first round game 3. We'll go ahead and run that, and we get our single row, because remember that's what the database, or that's what the web scraper was depositing, was a single row for each of those. I think you need collect, yeah, each of those games. There we go. So collect just helps turn that. You can see actually over the top of that, it sort of looks like a tibble just above that, but you can see it says database SQLite 3.35.5. It's this sort of lazy query or lazy query. So once you pass collect, it basically will turn it into the data frame that you then want, right? So there we go. So now it's, yeah, there you go. It's a tibble. So it's a 1 by 12 tibble with the 12 bits of information that we pulled with the web scraper. So that's some game info. And now we can go back to get the play of interest. So within that game, we then want to pull out a play of interest. In this case, it's going to be listed here as ID number 12, which was from Ellis's sort of little row number function there, which sequenced along each game and deposited a single value for every new row. So there we go. So its possession is Milwaukee. It's 10-10 in the game. The score is 5-2, so it's super early, obviously. And then you can scroll. There's the play details. Chris Middleton makes a 23-foot three-pointer. Giannis gets the assist, and there's all the information. So there's quarter one, play number, ID 12 is what we pulled out. Okay, so that's pretty cool. So let's talk about some joins. So joining is basically the way that we've done this a few times with different data sets, but we'll do it officially here, doing it using R and SQL. So joining is a way for us to connect two data sets together based on some key that is similar between the two data sets. So the column header needs to be the same if we're going to join on that. If it's not the same, we have to put a little by argument within our join, and we're going to do that here in a second. So we've got some play info, and we've got some info about the game ID. So we'll pull that stuff in, and now we're going to join this all together. So we're going to take the game play-by-play data set, which we just pulled in. So there's the whole game. And we're going to take the game info, which has stuff about the capacity of the crowd and the betting odds, etc. And what we're going to do is we're going to left join. So left join is basically saying keep everything in the left data frame, in the X data frame. So in this case, because we start we start our code with game _ P by P. We're starting with that data set. That is considered the X data frame. We're going to keep all of those rows, and we're saying, hey, inside of the Y data frame, we want to join that up based on this key column called game ID. So we're going to join that up, and we're going to keep all of the rows in the left column. If there's nothing in that right column that joins that left column, it just deposits NAs. If we flip this and we did a right join, it'd be working the other way. So we'd basically be saying keep everything in the game info column, drop NAs wherever it doesn't find something in the left-hand column. If we do a full join, it says smash them all together, and anywhere there's no combination, go ahead and just create NAs. If we do an inner join, it says only find the two similar matches within the X and Y columns. And then the last one, which I never appreciated until I started doing more data cleaning, is the anti-join, which is basically saying, I can't find anything. Here's the rows that I can't find any matches for. And that helps you say, like, geez, what the hell's going on in my data set?
Why are
these not working? Yeah.
Why aren't they matching? And go.
So we're gonna do a left join though. So we've got our data.
It's like this is the one that I feel like is the most intuitive.
Yeah, and if you're in SQL, those names are the same. It's going to be right join, left join. In SQL, I think if you just use the word join and nothing else in front of it, it defaults to a left join if memory serves. I believe that's how it usually works. So
SQL DBAs Give
Exactly.
us your wisdom.
Someone correct me if I'm wrong there.
Subscribe and tell us your wisdom.
Exactly. Exactly. So we're going to do a left join. You did a little mutate there first, which is to turn the numeric into a character.
To add it in, because the game play-by-play information technically doesn't have the game ID. And so we needed to add the game ID, and we know that because we know the table that we pulled it from.
Yes, got it. Okay. And so we're going to do this left join. Now here's the instance where we don't have a similar key column to join on. So we add it. You have to actually specify that, hey, in the X data frame, I want you to take that column game underscore ID underscore number and join it up in the right data frame or the Y data frame with what they call column game ID. If you were doing this in SQL, you'd do an on. So you'd say join game play by play on game info by, this equals that, and then you'd be rolling. So we run our join. It works. We got full game info, and you can see the at the furthest there's the information about the referees and the capacity, and we could do a view and actually look at it all, and it should be the same info all the way down. It's turtles all the way down. Yeah. Right? So there we go.
It's no different. This is, once again, we are kind of giving a simple example of this, but there might be a case where you might have like additional information that would be like, you'd be merging on more than just one key. And often that's the case where you're merging on more than just like game ID. It'd be game ID and like play ID or something like that. If you had additional information like which referee made that call or something like that. I think we're going to actually get into that in a future episode.
Yeah, joins can get pretty long and complicated depending, like if you were working, let's say, across seasons, you'd be merging on game ID is probably, maybe it's not unique across seasons. I don't know how ESPN does it. Yeah. So season might be a variable that your year, whatever it is. So there you can join on as many columns as you can dream of. The one thing I will say about joins to keep in mind is that if you don't specify by, and you have multiple columns that have similar information or similar header names, you end up overwriting things, which can be problematic, or you end up with weird joins and you get weird information returned back. So always know what your column headers are and what you're explicitly trying to join on. Otherwise, you could get some funky things back.
It's better to be explicit than implicit.
Correct, yeah.
Well, it's safer.
Safer, much safer.
All right. So this is a case where we pulled all the data into our local machine from the database using collect. This worked here because our data were not that large and we have a ton of memory. I think I have 32 gig in this, which I guess isn't all that much compared to some places, but it feels like a lot for me.
Yeah.
So this worked because we could pull it all to memory, but there are cases where you're doing joins that don't work in memory, where the data just is too large. Like you're doing a join, then you do some aggregation, and that's when you can pull it into your computer. It's once we've done that aggregation and summary. So let's quickly go over how we do it with SQL using R. And it really is more or less the same syntax. It's actually pretty nice. Because of the dbplyr and the underpinnings that it provides. So you use the table connect to the same table. We're going to do that same mutate. We're going to do the same left join. So this is identical. The only thing is we didn't do a collection before. It's all still here. And so we can run this and we get the identical information.
In the lazy query format, because we didn't do the collect. Yeah.
But let's quickly take a look. I did that so that we could look at the actual query itself.
Right.
Because look at that beast.
So let's see. We have select. So we're selecting the columns that we want.
These are all the columns. And so I believe this is an intersect between the two columns.
Yeah. And this is interesting. The from here is interesting to me because this is an interesting SQL. It doesn't look like SQL that I would normally write.
Yeah. So once again, this is a case for this is effective in that it'll get it done, but this probably also won't be the most efficient query code. This is when you take this to your DBA if you don't speak SQL at all, and you can go, hey, this is what I'm trying to do. Can you make this better? And they'll go, oh yeah, no problem. But at least now you have a language to communicate with each other. And so what this is saying, I believe, is basically select all the columns in this game 401327879, and call that left-hand side. Read game IDs, left join with game IDs as the right-hand side on these things. And so I don't think you actually need to... Oh, it's probably because of this conversion there with that mutate in there.
Yeah, this is an interesting query. Okay, yeah, cool. I mean, it works.
Yeah, it's functional.
Yeah.
Which, at the end of the day, that's all that matters, right? And
so what if how do we decide which one is more efficient?
More power, baby. No. So the way we can do that is using the library that we referenced earlier, which is micro benchmark. So this is benchmarking, which is we'll have two sets of code that we'll run, and we will time them. And we'll run each one of them 100 times so we get a representative sample. So this is something you won't want to be doing with code that takes like 10 minutes to run, because you'll then run it 100 times. So that's going to be 1,000 minutes to run. And congratulations, you've now wasted a full day, I guess.
Run it and go, hit enter, and then go get some coffee.
And go, sorry, boss, profiling. Don't do that. But so what we're going to do is we're going to use the function micro benchmark. We're going to call the first timer set of code, the code that we're going to be timing, is SQL join. And this is that SQL join that we just ran under the hood there. Between these curly braces, which tells micro benchmark to consider this as one set of code. And then we're also gonna call the second piece load to memory. And this is the piece of code where we read it from the database and then do our left join on our computer. And we want to compare which one it runs faster. And so we're going to run it with by the default number of times micro benchmark runs these things, which is running it 100 times. So like I said, this can take a moment, but here it actually ran pretty quick because these queries actually don't take all that long. And so now we can quickly print the micro benchmark, and so we can see the SQL join chunk of code ran on average in about 10.69 seconds. Or milliseconds. Milliseconds. Much faster than seconds. Yeah. And load to memory took a little bit over double at 22.88 or 89. So just looking at those two numbers, you can immediately see the SQL join is going to be twice as fast. Often. It's not all the time. It could. I mean, that's why they do this benchmark, because there's things that run in the background, and so there's a range of times they'll run. But on average, the SQL join is going to be a little bit faster than loading them both into your memory and running. Granted, it's also in the millisecond range, so really functionally do what you want, do what feels right if you can fit it into memory. But you can also use this auto plot here, and it's going to show us this pretty little plot.
It's a nice little violin plot of mirrored densities. There's the load to memory, and then there's the SQL join.
Yep. So there you go. So now you can kind of look to see like the bulk of these. The SQL join is definitely around or below 10 milliseconds, and the bulk of load to memory is around
22-ish
milliseconds.
Yeah.
And so you're just it's going to be faster to do this, and of course your timing is going to vary based on your computer, what's going on there. So maybe get to know your computer as well. Because this also means that there's read and write speeds involved with our to disk and from disk and whatnot. So there's a lot of things to consider. Since this isn't like a true database situation, it's not apples to apples. But I wanted to do that comparison to show you why you might do this. And this definitely gets better when it's going to favor the SQL calls more as the data gets larger, because your computer is just going to chug, especially if it starts filling up memory. So offload the work to a different computer So
Yeah, there you
your
go.
computer doesn't have to warm your coffee.
That's right.
There you go. Now let's disconnect because that is the end of our script for today. So thank you all so much for joining and learning a little bit about joins and how we can call them in SQL.
Yeah, awesome. And thanks, Tim, for the question about joins and kind of how they work in SQL and R, and how we can use them.
Yep.
So that's good.
All right. And so with that, let's call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and you can find me on Twitter at OSPPatrick. And Tidy Explained is on Twitter at Tidy_Explained. We're also on Gmail, which is how Tim got a hold of us. So we'd love to hear from you as well. Tidy.explained@gmail.com. Otherwise, if you don't want to send us an email, you can go on the GitHub repo and take out an issue and ask a question there. Or probably the most common way for people to hit us up is to like and subscribe on the YouTube channel and just drop their questions or comments directly underneath the video of interest. And with that, that's a little bit on joins with databases inside of R.
All right. Thank you all so much and keep on exploring your world.